I just started a new recording so that I can post this recording. Okay, so I have just a very short lecture. Let me share my screen. Um, so how was the exam? Any too hard, too easy, too long, too short, just right?
Too short.
Too short.
Too many questions and
Too
very
many
short time.
questions, yes.
Short time.
Yeah.
And yeah, 2 hours was not enough for all these questions.
Okay. Well, that's a good data point because I will have to put together a final exam too. And all right, well, I guess when
Professor,
everything is
so the quiz and the notebook both have to be submitted in 2 hours, right?
yeah. Um, well, I think the multiple choice quiz got submitted automatically at the end of the 2 hours, and then the notebook, yeah, you had to submit that yourself.
No, the quiz was not submitted automatically.
Oh, it wasn't. Um, did you then have to submit it?
Yes, I submitted manually.
Okay. I thought it was automatic. I have a lot of problems with Canvas. I keep thinking, getting rovers onto Mars was easier. So, okay, well,
I have one comment on
yeah.
one of the multiple choice questions.
Mhm.
Just how it was worded for that Python statement question.
Python's okay.
Yeah, it was more of that.
Okay,
I,
I
oh, okay.
go ahead.
Well, I was just gonna say that how it's kind of worded is kind of usually when I think of assigning like a list to each variable, I wouldn't put the word value in it. So I kind of read it as assigning each value in the list to the variables per.
Okay.
That's what kind of tripped me up.
Number 8.
Yeah, the list value. I'm used
Okay.
to the
Well,
word value individual.
we're unpacking this list. So A gets value 1, B gets value 2, and C gets value 3. Looks like the first one.
Yeah,
Well,
I went through it fast. I'm just commenting on that. I've heard
uh,
the usage of value list value to mean individual parsing. That's why I got confused.
um, that's a list. Oh, I see. Um, yeah, I guess what I tried to say here is with this incorrect answer is that A gets the value of the list, B gets the value of the list, and C gets the value of the list. So A, B, and C each end up with a copy of the list. And of course, that's not correct.
Yeah, hindsight I get. Yeah, in hindsight I got that. It was just when I read it fast, I just saw
Yeah.
value, so I thought it was like already parsing.
When it comes to putting together these exams, believe me, the multiple choice questions are the hardest because I have to think up the question and then come up with 4 or 3 incorrect answers that are plausible. Yeah, so because you don't want the correct answer to be so obvious, and that is really hard. Coming up with problems is that you have to sit down and solve. That's actually kind of easier. Okay, all right. So, well,
Professor,
yeah.
just a last note. Actually, we had to do both the notebook and the quiz, so time was not sufficient. If we had, I mean, quiz separately for half an hour or so, it would be helpful actually, because we have so many calculation problems in the quiz.
Um, yeah, there were a few. I was debating whether or not to do that because usually I don't put any calculation problems in the quiz. It's either you know the answer or you don't. But I thought I put in some simple calculations, but maybe they weren't so simple. Okay. Well, I'll get an idea when the exams are graded. If I went too far or didn't go far enough, and so I definitely will make adjustments for the final exam. Okay. All right. I want to just cover a few miscellaneous topics related to what we have been talking about. Uh, let's see. I don't remember if I showed you a slide like this. I think I mentioned, or at least had little notes that said that when you're coming up with these hypotheses, people always say, well, which should be the null hypothesis and which should be the alternative hypothesis? And the rule of thumb is that the null hypothesis is the one that has the equality. So either is an equal, less than or equal, or greater than or equal. Okay, that is the null hypothesis. Then the alternative is the inequality, not equal to, less than, or greater than. Okay, so that's the rule of thumb. Okay. Now, people always say, why is the wording, you fail to reject, or the wording sounds very almost legalistic, I guess. Well, the idea is that, remember, you're taking a sample, and unless you have the entire population, you don't know for sure. And so, there's all these probabilistic factors that come in that, well, we only took a sample. So, we can never accept the null hypothesis. We can only fail to reject the null hypothesis. So it's, statisticians try to be very, very precise in how they word things, and who am I to try to change that wording? So I tried to make sure that my slides had that precise wording. And if you look online or look in a statistics book, you're going to find this kind of wording. The idea is that unless you have the entire population, you can't be 100% sure. You only have a sample. Okay. All right. Now, a small hypothesis test. Okay. Let's say that your sample size is small. Okay. Now, remember, we talked about the central limit theorem and how wonderful it was. But central limit theorem really only works when the sample size is not small. And I think another rule of thumb is that the sample size should be greater than 30 before you can apply the central limit theorem. Okay. Now, if we have a small sample, okay, if the population where this small sample comes from is normal, then we can do hypothesis testing the same way that we did for a large sample. Now remember, small sample, but the sample comes from a normally distributed population. Okay. If it's not normally distributed, then you cannot do this. Okay. Now, but if you have a small sample, you have to use the t, not the z that we were using before. We have to use the student's t distribution. And then this is the formula. And then again, this n-1 degrees of freedom. Okay. So let me give you an example. Okay, so real estate agents claim that, boy, in their neighborhood, homes for sale stay on the market for under 90 days. Okay, so they take a random sample of 9 homes and they average 77.4 days on the market. Okay, with a standard deviation of 29.6. Okay, so can we test the real estate agent's claim that homes are staying on the market for under 90 days? Okay, so again, the null hypothesis has the equality. So we're setting up the null hypothesis as saying that mu, the actual mean, is greater than or equal to 90 days. And the alternative is that it's less than 90 days. Okay? Now you can't turn these greater thans and less thans around. It just depends on how you decide to write the hypotheses. Sometimes it makes sense for it to be always a greater than, or sometimes it should be a less than. But remember, the null hypothesis has to have the equality. Okay? All right, so this is the way this problem is written. Okay, so the null hypothesis says that the actual average is 90 or more days on the market. And the real estate agents, I guess, are claiming that it's less than 90. Okay. All right. So we calculate. So we're going to use our formula here. Standard error of the mean is this. Okay. Now we then look up the critical t-value. Okay. We want the alpha to be 0.05. And we look that up with degrees of freedom of 8 because there were a sample of 9 homes, and we calculate our test statistic. Okay. Now it turns out the test statistic minus 1.28 is greater, okay, than the critical t-value. Whoops. Sorry. Sorry. The test statistic that we calculated was greater than the critical t-value, which is here. I scared myself for a second there. Therefore, it was not in the rejection region, okay? Because this is a less than, we were looking at the lower tails, okay? Had we turned the greater thans and less thans around, we would have been looking at the upper tail. But remember, it's symmetrical, so it just depends on how we word the hypotheses, whether it's a lower tail or upper tail. The way we did it, it was a lower tail test, okay? So there was insufficient evidence to support the claim. Okay, so we're going to reject the null hypothesis. So there's insufficient evidence to support the claim of under 90 days on the market. Okay, so so this is an example of small sample hypothesis tests. Okay. All right. Another common test that statisticians do when they do experiments is they want to test the difference between two population means. So here's population 1, and it's got, you know, a mean of mu sub 1 and standard deviation of sigma sub 1, and there's population 2, and you know here's a mean of mu sub 2 and standard deviation of sigma sub 2. Okay, so they have two populations, and you want to test the difference between the two populations. Okay, and so you take a sample from each one of them. Okay, so here's a sample, and here's a sample, and then you calculate the standard deviation of each of the two samples. Okay, all right, so then we plug into this formula and get another z-score, and I'm not going to try to derive the formula, but here's the formula that you use. Okay, so N1 and N2 are the sizes of the two samples. So these two sample sizes are not necessarily the same size even. Okay, so all right, so we have this formula, and let's take a look at the use of this. Okay, so here we have we have some sort of exam, and the question is, do male students score better than female students on this exam? Okay, and so we're going to compare the means. Okay, the mean of the male scores and the mean of the female scores. Okay, and so here we go. We're going to set up the null hypothesis to be that basically the two means are the same. Okay, and then the alternative hypothesis is that the looks like the male students have higher scores than the females. Okay? Assuming that mu sub 1 is male and mu sub 2 is female. I guess I didn't make that real clear. Okay, so that's our hypotheses, and we're going to do an upper tail test at the 0.05 level of significance. Remember, the 95% confidence level is very, very popular. Okay, so alpha is 0.05, and we look up the rejection region, and there's that number again. So z is greater than 1.645 will be our rejection region. And it's an upper tail test because it's a greater than, okay? All right, so we plug in all the numbers and we get 1.83, our z-score, okay? Well, 1.83 is, has to be greater than, okay, so we are, okay, what happened here? Okay, okay, so the z-score is that, and it is in the rejection region. Yes, so therefore we reject the null hypothesis. Oh, it's getting late. And I'm hungry, so my brain isn't working too well. Okay, so yes, we do reject, and therefore we have to accept that the male scores, the average male score will be higher than the female scores. Okay, according to our test of the population means. And this is for a large sample, because n in both cases is greater than 30. Okay, and this is X bar. Okay, I guess that bar didn't make it all the way across, did it? And then here's the sample standard deviation. Okay, all right, let's take a look at small samples. Okay. Now, so this formula is for large samples, you know, N1 and N2 greater than 30. What happens if you have small samples? Okay. Well, again, we do a T. Okay. All right. So we do what is known as a pooled estimate of the common variance. Okay. And so yes, this is what it looks like. We're pooling the variance between the variance of the first small sample and the variance of the second small sample. Okay, and then the test statistic. Okay, well, it's going to use that pool right there. Is this. Okay, and then of course we have to use the degree of freedom to look up the t-value. All right, let's take a look at this. Okay, so now we have a small sample because we only have 20 males this time, and so we have to do a small sample. Okay, we can do large sample only if both of them are greater than 30. Well, here male is only 20. All right, so here we go again. Now here we did make a change. This was a greater than. And now we're going to say not equal to. So that means it's a two-tailed test, okay, both lower and upper. And then we divide the alpha, you know, in half and distribute it between the two tails, okay? Okay, two-tailed test, 0.5 level of significance, alpha is 0.05. Degrees of freedom, okay, we add up these two numbers and subtract 2 because you know they're two samples, and we get 56. And then we look up in that table and get a critical t-value of 2. Okay, so we reject because we're doing a two-tailed test if the test statistic is less than -2 or greater than +2. Because the critical value is 2. Okay. All right. Well, we plug in the numbers and do the math, and here's our looks like. Okay, what do they come up with? We come up with this minus 0.21, and of course it's not less than -2 or greater than 2, and so we fail to reject the null hypothesis. Okay. So, right, so that is how we do testing with small samples. And I know, you know, I just really rushed through this and just gave you the formulas and one example, but I think later on maybe I'll be giving you some more practice using these formulas. But it's really just sort of recognizing what the problem is, and then pulling out the formula. Okay, is it a large sample or a small sample, and then just plugging in the numbers. Yeah. Okay.
Professor,
Yes.
are we gonna cover the midterm materials in the final exam?
Well, the way my finals always work is that I'll say it covers the entire semester, but with more emphasis on the second half. Now, so what's coming up? We haven't talked about regression analysis yet, and so and that's a very important part of statistics is regression analysis. We're going to do both linear regression and polynomial regression. So regression is not always a straight line; it could be a curve of some sort. And then related to regression analysis is time series analysis. We want to analyze how values can change over time. And it's kind of unfortunate, but because of COVID, there are lots and lots of these charts that analyze the number of deaths, over time, or the number of people in the hospital, and then it draw all these nice curves showing that, oh gosh, it's going up or it's going down. So we need to see how to do that. And then what I want to do is take a pause and actually go into machine learning and show you how some of the things that we've been doing relate to machine learning, because presumably your future classes will be machine learning, and you'll be doing machine learning projects. And so I really want to show you that this was relevant, that you weren't taking a math class just because they made you take a math class. Then we'll finish the semester by going into linear algebra, and a lot of the things that we've been doing can be done with matrices, and especially when you have a lot of variables and whatnot, you can load it all up into matrices and do various matrix operations to solve these problems. And of course, Python has these wonderful matrix functions, and so it's just a matter of setting up the values into the matrices, and then you just call the functions, and off you go. Okay. I was reminded by the department that there was actually a fourth math topic, probability, statistics, and linear algebra. And they said, oh, Ron, what about optimization? That was supposed to be the fourth topic. And I said, well, how am I going to fit that into this semester? I'm already rushing through and cramming all this stuff. And so I'll see if I can at least say a few words about optimization and finding minima and maxima and all that good stuff. If you've taken courses in operations research, you encountered all this. So I'll see if I can't squeeze it in somehow. We'll see. But yeah, I kind of feel like I'm already cramming a lot of stuff in here. I don't know, maybe I go a little too far in each of these topics, and if I back off a little bit, then there'll be time for that fourth topic. But we'll see how it goes. Okay, so that's what I had planned for the second half.
Professor, I actually when I'm going through these tailed topics, I'm confused when we have to take the one tail and when we have to take two tail.
Oh, okay. Well, it's not that hard. You look at the well. First of all, null hypothesis always has the equality, and then you look at the alternative, and if it's not equal to, then it's a two-tailed test. And here, go back to the previous, whoops. That wasn't the right thing to do. Okay, go back to a previous one where there was a greater than or less than. That basically tells you whether it's a upper tail or lower tail. Okay. Okay. Here. This was a greater than, and so it's an upper tail test. If it was a less than, it'd be a lower tail test, and if it was a not equal to, then it's a two-tail test. Okay. So that's that's the way it works. Okay, any other questions? Okay, so a few of you said you were not able to submit. So why don't you send me a okay, send me an email message. And, no, okay, I will open up the exam for 1 minute. And so this is your very last chance to submit. Being very generous. I've been told other professors just say, well, too bad, you get a 0 on the exam. I'm not quite that bad. All right, so I'm going to stop sharing, and then I'll still have my mic on. The rest of you can leave. I mean, there's nothing else I'm going to do, but I'm going to open up the exam, and now only the people who cannot submit, because if you submit again, we will see that you submitted more than once, and then that's not good. All right, so hang on. Okay, let's see if I figure out how to do this. Okay, first of all, I gotta find the exams. Okay, so let's see. See, I gotta find out exactly what time it is now, so I can add another minute to it. Okay, hang on. Okay, I'm opening up the notebook, and okay, so be prepared to submit the notebook when I say do it. Hang on. Okay, so it is now 8:47 according to my clock here. Okay, 8:47. It just turned 8:48. So hang on, I'm going to make it 8:49. Okay, you should be able to submit the notebook. Okay. Okay. All right, then I'm going to open up the multiple choice, and then you should be able to submit that. Okay, hang on. Find it. Here it is. Here it is. Edit.
Thanks, Professor.
Okay, and I'm going to open up the multiple choice. Oh, that's interesting. Okay, multiple choice. You should, okay, are you able to submit the multiple choice?
Yes.
Oh, okay, all right, so I'll assume everybody has submitted, okay? All right, then I'm going to log off. Okay. Good night, everybody. Thank you for coming.
Professor, when
Yeah?
you'll be sharing the solutions for the notebook?
I will for sure by next Thursday, but maybe I'll post it earlier. I
Okay,
have
thank you.
several midterms to provide solutions to, so it's going to take me a little while. Okay. All right. Thank you for coming. See you next week.